Good evening, everyone. Welcome back. Today is the final session of for our Unit 2 in our value added course, and we are going to bring everything together with some hands on work in Jupyter Notebook. By the end of this session, you will not only generate and analyze data using NumPy, but also apply the pre-processing techniques in a mini case study scenario. So let's just get started, and we are moving towards our Jupyter notebook. I hope you are seeing my Jupyter notebook, this screen. So let's just start it with NumPy mini project. I'll just give this name NumPy mini project, in which we will create smart home sensor analysis. Okay. See, okay. Accept this. Okay. So we will name this notebook NumPy mini project smart home sensor analysis. So the purpose of this project is to show you how you will generate data with NumPy and perform some basic statistical analysis and create some simple visualization also with matplotlib. So first of all, what we will do, we will import our libraries first, as we have done earlier. So we will import NumPy as NP, and we will then import pandas library. Sorry, import pandas as PD, and because we are doing a visualization also, so for this we will use this library matplotlib. Okay, so by importing this library you will be able to create charts. Then pyplot as plt, so we will import this library. Okay, and one more thing, because in this we are generating the data, right? So it will be a sequence of random numbers, so we will generate some random numbers. So we will use, just I will also see it, this line reproducible random numbers. So how we will create, we will write np dot random dot seed. Okay, seed. And again, next thing, we will make plots inline. So for this we will write modulo matplotlib inline, and we will execute these cells. See here, it is executing, it is showing asterisk now. So it means that it will executing these libraries. So we will wait. Yes, now it gives this number 1. So this cell is executed now, right? Okay, now let's just this see what these lines of code really means. First of all, we will import these libraries, and then I write np dot random dot seed 42. What does this mean? Uh, it sets the seed for NumPy's random number generator, right? And what is the seed? A seed is a starting point for generating a sequence of pseudo random numbers. So using the same seed ensures that every time you run the code, you get the same random numbers. And why it is useful? Because in machine learning or simulations, you often want to get the same results every time for consistency. So it makes it easier to test and debug code since the random results are predictable. And seed value can be any integer, and using when we use the same seed, it will give the same random numbers. And when we use a different seed, a node seed, so it produces different random sequences. So for this we will, for generating a sequence of random numbers, we will use this code. Okay, and this matplotlib inline, it tells Jupyter notebook to display matplotlib plots directly inside the notebook, right below the code that produces them. So without this, plot might opens in a separate window depending on your environment. Okay, so in moving further, we will go to the next step, which will generate synthetic smart home sensor data. Okay, means we will create 1 week, sorry, we will create 1 week of hourly timestamps and generate temperature, humidity and energy. Humidity and energy. So let's just get started. First of all, because we have to create a 1 week, right? So we will take a variable periods is equals to 7 into 24. So this multiplies 7 days into 24 hours. Okay, means 1 week early. It will create timestamp, early timestamps for 1 week. Okay, and then we will start. We will select initial date. We will set 13 September. Let's see, 2025. We will write the date in this format: year, month, and date. 1 3. Okay. Single quotes. Express it in single quotes. This assigns the string, to the variable start. Okay, and it means this is the starting date for some kind of time series, schedule, or date related operation. Like we are creating hourly data starting from this date. Okay, and after this, so let's after this we will create a timestamps, and after we do this, timestamps is equals to pd dot data range. Now this is using, and we will give a range. Start is equals to start, means will start with this date. Okay, start, and periods is equals to periods means it will stop when our whole entry will be completed. Uh, and we will set the frequency is equals to h. Okay, now we will break this down. Just see that this pd.data range, this is a pandas function that generates a sequence of dates or timestamps. So think of it as a timeline generator. And this start, it will tells the pandas that starts the timeline from this date. So in our case, this will start from 13 September 2025. And this periods, this tells pandas generate this many points in the timeline. So because we just calculate this 7 into 25 24, it will give 168. So it will um, uh, give 168 because we want 1 week of hourly data. And then for frequency, we have set it h, that is hourly. Yeah, it means pandas will create points every hour. Okay, now moving further, we will do, now we will create an array. We will take ours is equals to np dot range periods, and we will take daily phase. Okay, I'll daily phase hours modulo 24 divided by 24.0. Okay, so what it does, why we are doing this, actually this np dot arrange generates an array of integers from 0 to n minus 1. You have seen this earlier. Okay, so when I write periods here, so how many entries, how many elements would be there? It would be 168 elements. See, 7 into 25, 24. So it would be 24 elements. This means 168 elements. This means 0 to, so ours becomes 0 to 167. Okay, meaning every number represents an hour in our week long timeline. And this hours modulo 24, this modulus operator gives the remainder after division. You all know very well. So this hours modulo 24 will reset every 24 hours because a day only has 24 hours. So otherwise it will be like this, 0 1 2 3 24 and 25 26 27 and so on. But we have to reset it now, for after every 24 hours. So we will divide it by so this hours modulo 24 will give this data like this, 0 to 23, and then again it will reset to 0 1 2 and so on, right? So this gives the hour within a day, ignoring which day it is. It will not go on that. Now why I'll divide this by 24, we divide by 24 to normalize the hour into a fraction of a day. Means resulting the resulting whatever with the values result from that range from zero point 0.0 to just under 1, means 0 to 1. So this daily phase tells us how far are we through the current day as a fraction. And why we are using this, because it is useful in time series simulations where you want to model daily life cycle like temperature, like energy usage. Okay, so this value repeats every day because of this modulo 24, right? Now after that we will set the temperature base. Okay, so temperature, it will be a daily sinusoid, plus we will give this a slight trend. I will and plus we will give some noise, means we will generate some random numbers there. So we will take temp base is equals to, first of all, what we are doing here, we will set this temperature baseline. We are setting this baseline as 20, right? So this is the average temperature plus baseline. Then we will divide plus we will adding 3 into np dot sine np dot sine 2 into np dot pi into daily phase minus np dot pi. So this is the logic we are implementing, np dot pi by 3. What does this line means? We have set the average temperature, right, as 20, or we can say this is the baseline. Temperature will not go above. We have set this baseline temperature. Okay. Now this 3 np dot sine, this is the sinusoidal fluctuations. Okay, because we will show the temperature in a sine waveform. It will show like this. It will have the sine wave. Like visualization. So we will show these fluctuations with amplitude 3 degrees Celsius. Okay, and after that we will done this 2 into np dot pi into daily phase. It converts the fraction of the date, because we have this daily phase it has it, we have this daily phase in a fraction of day now. So but in sine wave it will understand degrees, it will understand the angles. So we will this formula converts fraction of the day to radians for the sine function. Okay, and this np dot pi divided by 3, it will be a phase shift which moves the peak of the sine wave earlier or later in the day. So it means we will simulate a daily temperature cycle around 20 degrees Celsius. So what happens if you means if you will increase this 3 to 5, you can write 5 here, because it is just we are setting the parameters on our imaginary this is all the imagination we are doing. So you can set these 3 number to 5. You will see the daily temperature, uh, larger daily temperature swings. Okay, now for after that, so this is the this will gives this sinusoidal fluctuations. Now for the slide trend, what I will do, I'll do temp, I will take a variable temp trend is equals to 0.05 into bracket hours per 24. Okay, hours divided by 24. Now this hours divided by 24 converts hours to days, because we are showing the in the date wise fluctuations, na? And meaning and this 0.05, it means a small linear increase will be per day. Uh, for example, 0.05 degrees Celsius per day. Meaning temperature, this means temperature slightly increases over the week, simulating a gradual warming trend. So if we change this 0.05 to minus 0.05, what happens? We will see a gradual cooling trend instead. So this will, I have take I have set this temperature trend. Now next thing which I'll do is we will add noise, and for that we will set the temperature. We will set the temperature temp base, means our timeline which we have set, plus temp trend, the slight trend which we have set, plus in that we will add noise. And how we will do that? We will generate a random number, np dot random dot normal, and we will scale it 0.8, and size will be periods, means 160 elements will be there. So what does this means? This np dot random dot normal generates random values from a normal distribution. Okay, and this scale we have set, it is for standard deviation, means how much random variation will be add. Okay, and this size means it will generate 168 values, 1 per hour. So we add realistic random fluctuations which will simulate a natural temperature variation. Okay, so when we combine this all, when we will combine this temp base will give daily sinusoidal cycle. This temp trend will give gradual warming over the week, and this random noise makes the data look realistic. So we have generated a simulated temperature time series for 168 hours with daily cycles, in which we have a small trend, means the temperature goes warmer and cooler, and when then we have this random variation, like sudden clouds will appear, or sudden um, wind will be get slow or uh, fast. Okay, so that like this. After that we will work on the humidity. How we will do this? For humidity, I will just write this for your understanding. We will it will loosely inverse of temperature, means temperature plus noise. So humidity is equals to 60 minus 0.8 into temperature temperature minus temperature dot mean, plus we will add some noise, np dot random dot normal will get a normal distribution, normal, and we will scale it is equals to 3.0, and size will be periods. Okay, and humidity again we will do this, we'll clip this. Humidity is equals to np dot clip humidity 20, and we will set the range 20 or 100. Now what I have done this, see, uh, we will subtract this average temperature from each hourly temperature. So if temperature is higher than average, then result will be positive, and if temperature is lower than average, then result will be negative. So these steps help us see how far each other's temperature is from each hour's temperature is from normal. And why we are multiplying this zero point 0.8, we will multiply the deviation. Okay, so we will multiplying it by deviation, and this negative sign means makes humidity go opposite to temperature. So when it is hotter than usual, then temperature, then humidity drops, and when it is cooler than usual, then humidity rises. So zero point 0.8 is just a scaling factor. We will not do this. We will not get this to not. We will not want this not too steep or not too flat. So this creates the inverse relationship we often see in real life. Means in hotter days we will get drier air. And why we are adding this 60? Because we will start around a base humidity of 60%, and then adjust it up or down depending on the temperature deviation. So think of it like on average humidity is approx 60%, but if it's hotter, so reduce it, and if it's cooler, then it will increase it. And this np dot random dot normal, this is again we will add some random noise, Gaussian distribution, and we will scale it by 3. This is the standard deviation 3, so values vary randomly about plus 3 plus or minus 3%. This prevents humidity from being a perfectly smooth line, because real data is never that neat. So it will makes that data looks natural and realistic. And after that we will this clipping this uh, we will do this clamp values. We will set this clamp values between 20% and 100%. Means humidity can't go below 0 or above 100 in real life. So here we set the realistic safe range, means 20% very dry and 100% means fully saturated. And this clamp value forcefully do the set the data within the range. So whenever means when it goes like less than 20%, but it will remain set to 20%, even if it is less than 20%. And if it increases above 100%, so it will forcefully set to 100. So this clip values does that. We will and we will set this because this is the realistic. On an average we have this humidity, so it feels like real data. Okay, because in reality we don't have 101 or 110% humidity. Okay, so that's why we will set this clip values. It will ensure data stay physically meaningful. So when we summarize it, we will start with base 60%, and we will adjust humidity opposite to temperature. We will give this inverse. We have this inverse relationship between humidity and temperature, and we will add some randomness to it, and we will keep values in realistic range, that is 20 to 100%. Okay, now we will set our data for energy. Okay, for energy it depends on time of day, means how much energy is consumed. And small, it has a small correlation with temperature also. So we will see, we will take a variable time of day factor, and set it first 0.5 plus 0.8 into np dot sign, then 2 into np dot pi into daily phase 0.4. Then we will add plus 1 and we will divide it by 2. Now what I have done, let's see. Now how we can model energy usage throughout the day. We know that people don't use the same amount of electricity or at all hours, right? So for example, at night most of us are asleep, so usage is low, and in the evening everyone is cooking, watching TV, using light, so usage will be higher. So the question is, how can we capture this daily up and down behavior mathematically? So we have first we have this wave idea. We use a sine wave. And why sine wave we will use? Because it naturally goes up and down, just like daily energy usage. So one full sine wave means one full day cycle, 24 hours. So we'll start with np dot sine 2 into np dot pi into daily phase. So this gives us a waves that repeats every day. We have used this function in this also, na? So we will use this 2 into np dot pi into daily phase. Now we will shift the peak. So means if we leave it like this, why we are doing this? If we will leave it like this, the peak will occur at midnight. So do people really use the most electricity at midnight? Of course not. So we will add a phase shift to -4. This -4. So the peak moves to a more realistic time, like evening. Now we will normal sine values goes from -1 to +1. So but energy usage can't be negative, right? So we will rescale it. So we will add +1 to it and then divided it by 2. So the values are always between 0 and 1, right? And now we will scale our variation. If 1 means full usage and 0 means zero usage, that's too extreme. Even at night some devices are always on, like the fridge, like the Wi-Fi router. So we do two things. We will multiply it by zero point 0.8. It controls how big the day or night difference is. And then we will add 0.5, means it sets a baseline, so usage never goes too low. So we get time of day factor zero point 0.5 into plus zero point 0.8 into this rescaled sine value. You can use your values also. So you can play with these values and see how your result will vary on this. So I'm taking these values, so the data will remain look like some realistic data. It will look like realistic data. Now I will write, this is for the, see, time of day factor. Now for energy I will write 0.7 plus 0.08 into temperature minus temperature dot mean. Then 0.4 into time of day factor, means the value which will retrieve from this time of day factor, plus np dot random dot scale, sorry, normal, and we will scale it to the standard deviation 0.05. Size will be periods. Okay, and again we will now clip this values. Energy is equals to np dot clip. We will set our energy within the range 0.2 to none. Okay, see, so the next this is energy equation. It says sets the base level energy to 0.7. uh, See, it will set the energy base level energy usage, like appliances that always run, fridge, router, etc. And this line will add some correlation with temperature, and this will be the time of day variation. So in evening it will be of higher usage, and in night it will be of lower usage, and this will generate some random noise, means small fluctuations, as we do this earlier. And this is the clamping, and it will ensure that energy never drops below 0.2, since usage can't be negative or unrealistically small, and none means no upper limit. People might use as much as they want. Now we will build a data frame. These are the values, means it will all based on this imagination of an individual, because we will generate this, we are generating the data. So these are all uh, we are applying actually logic. Okay, how we can we were applying some magic mathematical functions to generate the data. Now for to build the data frame, how we will do this? We will set the variable df pd dot data frame. Okay, and we will how we will create this? We will create this in a uh, dictionary dictionary. So for we have keys like timestamp, and of course in timestamps we will have these timestamps values. Then we have this another key, temperature in degrees in Celsius. So the values will be round off. We'll set the temperature, comma 2. Okay, and then comma 2, right? Then we will have another key, humidity, humidity in percentage, and we will also round off this value up to 2 decimal places. That's why we have written here 2. And we have this energy parameter as key in kilowatt, and we will also round off this np dot round, np dot round energy, comma 3. See, like this. Okay, and we will set the index. Means we will set the index to timestamp. Means we don't have the index like uh, 0 1 2. The timestamp will be our index. Okay, and so we will build this data frame like this. And just a quick overview, we will see how our data frame looks. So it will show a quick preview, this function. How we will do this? df dot head. I've already told you this earlier. df dot head, what it does. Hopefully we don't get an error. Let's run this, shift plus enter, and we will get this. I think it is syntax error. Let's check this. It is showing that it is invalid syntax. Okay, so we'll see here. I think I have done some small mistake, right? pd dot data frame timestamp, timestamps. Dot round quantity, energy in kilowatt, p dot round energy. And then we will set dot set index timestamp 929. So I think yes. See, I have put here this is slightly index, and this set index timestamp. Let's check. Now it says timestamps pd dot data range frequency. So module pandas as no attribute data range. We will see to it data range. Okay, we will see to it. So this the same module pandas has no attribute data range. Means I have this confusion. I again done this spelling mistake. Actually, it is date range. Okay, because we are setting the date now in a range. So it is date range. Let's again this run this. H is not defined. See, H is not defined. Yes. Finally. So we have created this data frame where we have column names. We have this timestamp set as index, so it will act as a index. And we have created this hourly data. One after every hour, it will create a data, and we have these three columns set for temperature, for humidity, and for energy. So I hope you will understand this much right now. Now moving further, now we will inspect the data. Okay, so we will print, we will know what type of shape it has. So df dot shape, it will give you the shape. You will see to it. Then we will print, we will know the info. We want this into a new line, so that's why we are adding this backslash n. Then we will print, means this df dot info. We'll call this function, and for quick descriptive stats, we will use df dot describe. I have teach these functions in unit 1, in sorry, in day 1. In part 2 I have discussed these functions. So let's just see. So this shape has 160 entries, right? It has 168 rows, and it has three columns: temperature, humidity, energy. So this will give the shape of this data. Then we for info, see, uh, this will give you that we have these columns, these three columns: temperature, humidity, energy, and these are all values are non-null, means no null values have in this, and it is of float data type. Okay, and when we will describe this, so you see, it will the give the count, means how many values we have. Then it will give the mean, the average values. Then it will give the standard deviation, how much the data varies. And then this minimum means smallest value, and this maximum value is in the column. And even the 25, this quartiles range, uh, right? And what do you understand by quartile? So, for example, you are cutting a pizza into four equal parts. So the first cut, 25% will tells us where the first slice ends, and the second cut, 50% means we are in the middle. So it is the median, and this third cut shows the where the three slices end and only one slice is left. So uh, this is the middle values actually. So when I write df dot describe, so it gives the whole data set, whole snapshot of the whole set without plotting anything. So This is how you will inspect your data. Now moving further, we do some statistics. Okay, we will create an array, we will create a numpy array, and we will do some basic statistics. So we will demonstrate how you will calculate median, mean, and standard deviation. Okay, so we will create a numpy array r dot temp for temperature. For temperature, we will create a data frame in which we have this temperature in Celsius to numpy to numpy. Okay, then we will for humidity also we will create an array df humidity will store in this array. The value will be stored in this humidity in percentage to numpy. Okay, and for energy also we will do the same thing. Add energy data frame energy in kilowatt dot to numpy. And now we will print temperature, mean, median, standard deviation, then minimum value, then maximum value. Okay, after that we will print the values. For mean we will use np.mean, and where we will apply this array temperature. Okay. np.median हमने ये डिस्कस किया था, जो स्टैटिस्टिकल पार्ट था हमारा यूनिट पार्ट 1 और 2 में. सो हम वही फंक्शंस यहाँ पे अप्लाई कर रहे हैं. np डॉट नाउ हियर standard deviation we will apply array dot and wait, की ज़रूरत नहीं है. We will now np dot min value, min array temp, and we will go put this implement apply this maximum function np add temp. So if I do this and run, see, it will look like this. We have temperature, means we have created an array of temperature and humidity and energy, and we have this mean, median, standard, minimum, and max values. So basically numpy arrays are more efficient for numerical computation like mean, median, standard deviation. So after that we are printing the printing the descriptive statistics for temperature. So this is just the label. So the output is easy to read, and here you calculate the basic statistical measures for the temperature data. So this np dot mean of array on array of temp means it average value of temperature. Then it gives the median value, means 50th percentile of temperature when sorted. And this will gives the standard deviation, tells how much the temperature values vary from the mean. And this will gives the minimum temperature in your data set, and this will give you the maximum temperature in your data set. So this block converts the temperature column into a numpy array and prints its key statistical measures. Now, to store it or more neatly, we will do one more thing. We will declare a variable as stats, and what we will do here, we will create a dictionary. We have this key temperature, okay, and in this we have this values. We have all these values: np dot mean, np dot I just copy this, np dot mean, np dot median, np dot standard. Okay, so I just copy this, control C and control V. I hope I not messed up this. Then we will again we will have again this for humidity as well. We will do the same thing, humidity. Just copy this again, control V. But in case of temp we will use humidity. We have created this array before, okay, so don't get confused. Humidity, and we will do this for another value, means energy also. Okay, same thing we will apply here, control V, but for energy we will use. Okay, np dot min, np dot max, and this will use yes. Okay, so, and after that we will write for k vals in stats dot items print f new line, whatever be whatever will be the key, name, 0, dot 3f, sorry, 3 floating point, dot 3f median, so equals to the line here, equals to the line here, and vals we are setting the index actually for each variable here. And you will see the output, you will understand what is going on. Median, and for standard deviation also, whereas 2.3f for minimum is equals to whereas 3 3f max is equals to vals 4. See, 4.3. So we'll set this. Wait a minute. Set this here. Okay, let's just check this. I think I have done vals 0. See, it will give you this neat and clean data. It will give you this clean data. So here stats is a dictionary where key is the name of the variable, temperature, we have humidity and energy, and this value uh, means a tuple of 5 numbers: mean, median, standard deviation, min or max. Okay, and why we are using a dictionary? In that it keeps all statistics together in one structure. So it is easy to loop through multiple columns through without repeating code. So for we have set for k vals in stats dot items. So this stats dot items returns pair of key values from the dictionary. K is the variable name, so like temperature, humidity, energy, and vals is the tuple of statistics for that variable. Okay. So when we will print this statistics in a formatted way. So this is an F string which allows embedding variables directly into a string. And this vals 0, 1 means this val 0 means mean, this val 1 means median, this val of 2 means standard deviation, and this 0.3f formats the number to 3 decimal places for neat output. And this new line adds a line break before printing each variable stat. See, here it is. So in short, this block calculates mean, median, standard deviation, minimum value, maximum value for each variable, and stores them in a dictionary and loops through the dictionary and prints all statistics nicely formatted, as you can see here. It is nicely stored here. Okay. Now the next step what we will do, we will now show a correlation matrix. Okay, we will create a correlation using numpy array. We'll see to it how we'll do this using numpy array. So for this we will take a variable, declare a variable, matrix is equals to np dot vstack. Now I'll get to this np.vstack also what it does. And here I will write all this array of temp means all these values, array of humidity and array of energy, right? And we will whatever be the correlation, it will store in the this core variable, and we will apply the function np dot correlation coefficient. Okay, we will use this on this matrix. Okay, and then we will print our correlation matrix temp, humidity, energy, and again we will print the, and we will round off these values. So np dot round, how will it is this correlation, we will round up to 3 decimal places. Now let's see, shift the center. See, uh, this now let's break this down. This np dot v stack, this this function stacks arrays vertically, okay, row wise, to create a 2D array. So here air temperature, air humidity, and air energy are stacked as rows. Right, so this shows temperature, this shows humidity, and this shows energy. Now we will compute the correlation matrix. This is how you will do this. This np dot core coefficient matrix. So this calculates the Pearson correlation coefficient between rows by default, and then we will print this. So, and what is correlation coefficient? It tells how two variables are linearly related. So when r is equals to 1, it is perfect positive correlation, and when r is equals to minus 1, it means it is perfect negative correlation, and when r is equals to 0, then it has no linear correlation. So here core is a 3 cos 3 matrix because we have three variables: temperature, humidity, and energy. And when we print this, you see this round. This will rounds the correlation coefficient to 3 decimal places for neat output. Okay, so in the output you can see the diagonal elements are always 1 because each variable is perfectly correlated with itself, and off diagonal elements show correlation between different variables. So when I see, you can see here this point minus 0.463 and this minus 0.463. So when you do recall the correlation, when we have these positive correlation, this means variables tends to move in the same direction. So, and when we have this negative correlation, means variables tends to move in opposite direction. And this magnitude tells how strong the relationship is. So when we have this range 0.0 to 0.3, that means it is weak. And when we have this 0.3 to 0.6, then we will say that it is moderate. Like in this case it is moderate, 0.463, it is moderate. And when we have 0.6 to 1, then we will say that it is strong correlation. So in this case, temperature and humidity, in between this weak we have sorry uh, we have moderate but negative correlation between temperature and humidity. And again when we see this temperature and energy, we'll see we have strong and positive correlation between temperature and energy, right? So this lines just explain how two variables are related using the off diagonal values of the correlation matrix. Okay, now we are doing some visualization. We will do some visualization now. First of all, we will plot the time series. So first of all, we will visualization. Means we are doing time series. Okay. So first of all, we will set the figure. Okay. PLT dot figure. By using this, we will set the figure. And so fixed size I will set into 12, 3.5. Okay. Means this fixed size is equals to 12 comma 3.5, sets the width to 12 inches and height to 3.5 inches. Okay, so it will be a wide and short figure for time series plots. Then in the next step we will do plt dot plot df dot index comma df temperature in Celsius. Okay. Okay. So df dot index means we will set this x and y values. Okay. So this df dot index will be the x-axis values, and this df this temperature data frame will be a y-axis values. So temperature readings, right? And PLT plot means it will draw a line graph connecting points in order. Now we will give the title and labels. So how we will do this? We will use for title we will use PLT dot title, and we will give the title. Let's say temperature over 7 days hourly. Okay, we will give this title. Then we will give the label. So for x-axis, sorry, for x-axis we will write here x label, temperature, sorry, timestamp, timestamp. And for y-axis we will give y label as temperature. Okay, in degree Celsius. In Celsius. Okay, let's see. Right now we will now adjust the layout by plt dot sorry plt dot type layout. And for visualizing the for displaying the plot we will just use this plt dot show. Okay, so again just recap this plt dot figure means this creates a new figure. Okay, and we will set the width to 12 inches and we will set the height to 3.5 inches. See, and now for this we will plot the temperature now. So this is x value and this is y value. So this df dot index will be x-axis, will be on x-axis, and this temperature in degrees Celsius will be on y-axis values, means temperature readings. Then we will add title and we will add labels. So for title, we have given this title temperature over 7 days hourly, and to x axis we will label it as timestamp, and to y axis we will label it as temperature in degrees Celsius. And when we adjust the layout, why we will do this? Because automatically it will adjust padding, so labels and titles don't overlap with each other. So especially useful when we for long x-axis labels like timestamps. And when we have to display, so this finally this renders the plot on the screen. So let's just run this program and see. Here you will see this time series plot. Okay, so at x-axis you will see this hourly timestamp over 7 days. Okay, 13 to 20th September, and each tick shows a date. Data points are hourly readings, right? So this axis tells us when each temperature reading was taken, and this y-axis in degrees Celsius represent hourly. It shows the temperature values ranging from 16 degree to 25 degrees Celsius. See here. Okay. So this axis tells us how hot or cold it was at each hour. And this line plot means this blue line shows how temperature fluctuates hour by hour. So there's a clear daily cycle. See, temperature rise during the day. During the day, it will rise. 22 till 24 approximately it was going. And at night it will fall. Means 16 to, it will fall up to 16 to 18 degrees Celsius. So this is a sinusoidal like fluctuations typically of a temperature variations. So what we will observe here, we can see here that peaks and dip occurs roughly at the same time each day. Eh, right, and we can see here that 16 degrees Celsius will be the lowest approximately, and approximately 25 degrees Celsius will be the highest temperature. And yes, there don't seem to be sudden spikes or sudden drops outside this range. So this means that no outliers is contained in it, and our data is smooth. And obviously I have not seen no obvious increasing or decreasing trend is also not showing there. So temperature is relatively stable across these 7 days. Now second plotting, for the second plotting what we will use, for the second plotting we will uh, create a histogram and scatter chart. Histogram and scatter plot. So plt dot figure, again we will set the width, we will set the height, and fixed size will be 6,4. Okay, then we will plot histogram. Okay, with x-axis, what will be the x? It will be the temperature. It will be the temperature. And we will this declare bends is equals to 20, and where we will give this title histogram of temperature. Then we will give labels. For x label we will give the title temperature in Celsius. Okay, And for y label, we will give the title as frequency. Okay, then we will adjust so that it cannot overlap, and we will display it. Why have I have taken this bins is equals to 20? So this means it will create a histogram which is basically a bar chart showing frequency. So bins is equals to 20 means we are dividing the temperature range into 20 equal intervals. So the height of each bar tells us how many temperature readings fall into that interval. And now what happens if we change it into 50? So bars become narrower and more detailed distribution will be displayed. Okay, and again we will give this title, and we will give this x-axis label, and we will give this y-axis a label, and we will use this tight layout to adjust the spacing so everything fits nicely. And this finally display our plot. So should press enter. This will be our histogram. You can see here. See, we just created a histogram of temperature data. Okay, we have sized the figure, labeled it, and displayed it neatly. Each bar shows how often temperatures appeared in our data set. Now, first, notice the title histogram of temperature here. This tells us that how we are analyzing how frequently different temperatures occurs in our data set. Okay, and now check this x-axis. This x-axis shows temperature in degrees Celsius. Each bar corresponds to a range of temperatures. For example, the first bar covers temperatures around 16 to 16.5, something like that. 16.5 degrees Celsius. The next is 16.5 to 17 degrees Celsius, and so on. So the notice temperature range roughly from 16 degrees Celsius to 25 degrees Celsius. So that tells us the minimum and maximum temperatures in our data set. Now check the y-axis. This y-axis shows frequency, which means how many readings fall in that temperature range. For example, a bar that reaches 50 here means 15 readings of temperature are in that interval. Now observe the shape here. Some bars are taller and some bars are shorter. So taller means more readings in that temperature range, and of course shorter bar means very few readings are there. So suppose for example here we have this tallest bar is around 23 to 20 to 23 degrees Celsius here. So which means most readings are in this range. So this is called the mode, the temperature that appears most frequently. And have you noticed which temperature range is the least frequent here? So you can see here around 24 to 25 degrees Celsius, since the bar is very short. So this histograms give a visual sense of how temperature data is distributed. Now for scatter plot, let's again first fix the size. What will be the size? Okay, it will be of 6 comma 5. Okay, and let's plot the scatter plot. Just write plt dot scatter, and in the x-axis we will write we will take these columns from data frame. Okay, so yes, we will write temperature here in Celsius, and again from this data frame we will write humidity in percentage. Now we will give this title, temperature versus humidity. Okay. Then we will label x axis uh, temperature in degrees Celsius, and we will plot, we will give y-axis a label named as humidity, because we are showing the relationship between the temperature and humidity. Will shows in percentage. Okay, and we will again adjust the layout so that it cannot overlap. Plot that tight layout, and we will finally display our, let's just check this. See, we have set the humidity, so we have set the size, width and height. Width will be 6 and height will be 5. And this plt dot scatter, it will create a scatter plot which is useful for seeing relationship between two variables. And on the x-axis we have temperature, and on the y-axis we have this humidity values on the humidity. So each point represents one row in your data frame, showing the temperature and corresponding humidity. And we will give this a title, temperature versus humidity, and we will label this x-axis as temperature and y-axis as humidity. Okay, and we will adjust this, and it will display like this. So what we are seeing here, we are seeing that on x-axis we have temperature ranges from roughly from 16 degrees Celsius to 24 degrees Celsius, and on y-axis we can say humidity ranges from roughly from 52% to 72%, and each dot here represents one observation in your data set, example temperature and humidity as at a specific time. Now what we are observing here, overall as temperature increases, humidity tends to decrease slightly here. So on the left side, 16 to 18 degrees Celsius, humidity is mostly between, you can see here, 60 to 67%. And on the right side, means here in this range 22 to 24 degrees Celsius, humidity is or lower, mostly between 52 and 60%. So this suggests a negative correlation between temperature and humidity. And how these points are distributed, see, here points are somewhat scattered, not forming a perfect straight lines if they are scattered. So this indicates the relationship is not just perfectly linear, but a general trend exists. So there are a few outliers. We can say here this around one dot around 19 degrees Celsius, and here this 72% humidity, higher than most others. And here this you can see also it is higher, 19 degrees Celsius. Yes. So these are some few outliers, you can say. And these outliers might indicate measurement anomalies or just natural variability. So this scatter plot shows a slight negative trend. As temperature goes up, humidity tends to go down. And most points you can see are clustered between 18 to 23 and 55% to Yes, here 55% to 65%. Most data points are clustered here. And outliers do exist, but do not dominating the trend. Okay. Now, next step we will do, we will create a box plot, which will show energy consumption. Visualization, which shows energy consumption. So, we will, first of all, we will copy our data. df dot daily, and how we will copy this? Just use the function df dot copy. Okay, here. Then after that, we will create a new column in df daily, in data frame daily. And what will that column calls? It will call as day. And we will, what we will do, we will daily dot index dot day. Okay, what it does, this creates a new column day that contains only the date part of the timestamp, year, month, or day, which I have earlier created, ignoring the time. We are not giving the time here. And why we are doing this? Because we have to group energy readings by day for daily analysis. Okay, now we will group the data. How we will do this? So we will create a variable to daily groups is equals to, we will group energy in kilowatt for, this is the day, this is for day, okay, whatever comes in, group in df dot daily dot by. See, this df dot daily dot group by, what it does, it will group the data frame by each unique day. And this loop will run over each group day, right? Group day for whatever be the day, and group is the data frame of that day. Okay, now, and this group energy dot values will it will extract the energy values as a numpy array for that day. Okay, so it will create a list of arrays, one array per day. So what will be the result? The result will like a daily group. It is like a list of arrays. Okay, now we will prepare the figure. Means we are now we are creating a box plot. So we'll set a size 10,4. Then we will box plot daily groups. Okay, and we labels is equals to strd for d in sorted of daily A dot unique. Okay, I think I write this. Okay. See, uh, this daily groups means we will create one box per day, and this labels will set the x-axis labels to the sorted list of dates. Okay, so what the box plot actually shows, it shows median energy consumption per day, middle line of the box, and it will shows the interquartile range and potential outliers. Okay, then we will give the title to it. We'll give this title daily distribution of energy consumption. उसके बाद हम देंगे we will give x label date dot y label, sorry, y label energy in kilowatt, and we will use again a function x ticks, and rotation is equals to 45. Now what it does, it will rotate the, then plt dot type layout. Okay, and plt dot show, it will show the final output. Just run this. It is df dh is name df daily is not defined. Let's check this. Let's check this. See, it shows here. Yes, I have again do the same very small mistakes. It actually is df underscore day. And again, what I have done is df dot copy. Here it says what day. Okay, df dot here it is df day. Sorted again. I have this df daily. Okay, daily groups. You dot go by again. Here I have done this spelling mistake. Dot title. See, here it will run. See, first of all, we will set the figure size to 10 inches wide and 4 inches tall. Okay, and this daily groups, this daily groups means the data to be plotted, means one box per day we will show. So you can see here, this shows the plot, a box plot with one box per day, showing the daily variation in the energy consumption. So tall boxes means high variation that day, and short boxes means low variation. And is there any doubt? Dots outside? No, we don't have our outliers. So with this, we are done with this mini project, smart home sensor analysis. I hope you will understand how we will generate, first of all, how we will generate this data, how we will generate the data from random numbers, okay, and then we have done some descriptive statistics, okay. We will count the values. We have calculated the mean. We have calculated the standard deviation, and then we have seen that for from numpy array how we can use this statistics calculation, how we will apply this statistical calculations, and then we will see here we will this correlation matrix between these three columns, how it is, how these three variables are related to each other, and then we have done this visualization. We have created this time series, we have created this histogram of temperature, and we have created this scatter plot, and for daily consumption, energy consumption, we have created this box plot. So this is the NumPy mini project. I'll share this notebook with you so that you can easily copy the codes and run in your notebooks, and also you can adjust these parameters, right? Because I have this is totally based upon our logic, how we are creating these, how we are setting these baselines. Here we have set the baselines as 20. Here we have set this baseline as 60%, but you can do the variations, you can change these parameters, you can change this tunings, and see how your graph will be displayed, how your time temperature will go, okay. So you can see that. So this is our first numpy mini project, okay. Now we will just do a small statistics, some pre-processing with our numpy array using a small case study. So we will see this. We will create a new notebook. We will create a new notebook. This kernel is starting. Please wait. So we'll wait for some time after it gets started. Okay, kernel is ready. Now we will give this title pre-processing with numpy. So where we will do a small case study. Okay. Now pre-processing with numpy means how using the numpy we will clean and normalize our data. Okay, and when we clean and when we first clean, we will first of all we will create the data, and then we will check the any missing values is available or not. Then we will handle duplicate values if there is any duplicate values. Then we will scale these the data, okay, which is called a normalization. And after it will pre-processed means it will normalize, we will prepare the data sets for analysis or machine learning, okay. So first of all we will import the numpy library as np, and Yes, here we will also do some visualization. So we will import this library mat.lib.pyplot as plt, and we want our graph to be just created here. We don't want a new window. So we will set this matplotlib inline. Okay, and we will execute this. See, this is executing. This is asterisk shows that this is executing, and once it is executed, it will give the order as one. So you can also see how in means which cell has run first, which cell has executed first, then second, and third, and so on. This is how you can see. So we will here we will do it will it we will generate a simple sensor data. Okay, and we will scale that data. We, so we'll see. First of all, we will create an numpy array, and how you will create, you have already studied. We will use this function np.array, and in that array we will just give the values 23, 25, and np.nan. I have told you that this function, what it does, np.nan, it stands for not a number. So it will give the null value here, 22, then 24, then 26, then again I have do this np.nan, then 27, 25, and 23. Okay, then for humidity we will again create this array np.array 55. We will give this values 55, 60, 58, and b.nan 57, 59, 61, and b.nan 56, 58. Okay, and then we will print first of all the original values, original temperature data. Print these values, and then we will print original original humidity data. Humidity. See, we have created a numpy array firstly. Okay, from the list which we have provided, we have this 23, 25, and you can see here is this null value over here. Okay, this np.nan stands for not a number, so it's used to used to represent missing or so this np.nan represent missing or invalid data. Okay, now how we will handle these missing values. So I have told you earlier also that there are two ways. First of all, you can either drop this remove rows with the missing values, or you will fill these missing values with the mean of that particular row. So I'll go with option 2 again. I'll fill missing values with mean. Okay, and how we will I will do this first of all for temperature mean. I will do np dot nan mean. Now, these are some functions. So I'll get to it. Then humidity mean, I'll set np dot nan mean humidity, this, and I will now filled. I've taken this variable temperature field, and in here I will write np dot where np dot is nan temperature, means the value which will be extracted from this np dot nan. Okay, temperature, and then temp mean, then temperature, okay, and again for humidity I'll declare this variable humidity field np dot where np dot is nan humidity, then I will write humidity mean and humidity field, and then I'll print here temperature with Nance filled. Temperature. Okay. And again I will write here humidity with Nan filled. Means after I have filled these missing values with mean. Humidity filled. Okay, let's just check this. See, now we don't have any null values available. We have filled this null values with the mean. Okay, here I have also this nan will become 24.375, and after 26 this null values will become 24.375 again, because the mean of these rows will be like that, will be 24.375, and in origin humidity will also see 58 here and 58 here, you can see. Now let's just break down this code what I have done here. See, np dot mean means it calculates the uh, average of an array but exclude this nan values. Okay, so it finds the average of all valid temperature values ignoring the missing ones, same as above, and but for the humidity array it will do for the humidity array. Now this line here, see this np dot where. See this np a dot is nan temperature returns a boolean array, true or false. So true means where values are null, and false means otherwise. And this condition I have written here, if this value is true, so it replaces each np dot nan means each null values with temperature mean. Okay, so this fills this missing temperature values with the average temperature. This is the formula actually, where this is how you will fill this empty values from the with the average temperature. And same we will done with this humidity values also. Same logic will apply. Okay, and then we will print the this filled arrays. So you can now see the arrays with the np.nan values have been replaced with the corresponding mean. Okay, so just recap this function. Np.nan means it computes the mean ignoring null values. Np.isNan identifies where null values are located, and np.where means where we have this replaces null values with the computed means. Okay, so this is how these functions work. Now we will now perform min-max normalization, which is also called feature scaling. Feature scaling on the temperature and humidity data. Now, what the goal? What is the goal here? Is we have to rescale the value so that they fall within a 0 to 1 range. This is often used in machine learning and data visualization to bring different features to a similar scale. So, what we will do, we will apply the minimum or maximum scaling formula. If you are remembering that formula, so you will easily understand how I have applied, how I will implement these values. And p dot min and again I will divide this and p dot max temperature filled minus np dot min temperature filled. Okay. Yes, and for humidity also we will scale the humidity values also. Scale humidity minus np dot min filled again np dot max humidity filled minus np dot min humidity filled, and then we will print our scale values. Scaled temperature temp scaled, and then we will print our scaled humidity. Humidity scaled. See, actually what we are doing, when you recall the scaled value formula, it is x minus minimum upon max minus min, if you recall this formula. So for any array like temperature field, you first calculate np dot min, which is the minimum value in the array, and np dot max, which is the maximum value in the array. And this give you the range of the data, and after that I have applied this scale value function formula here. I will write here in the, see, this scale value formula is, so you will understand, scale value x minus min divided by max minus min, if you recall. So that exactly I have this, just this apply this formula here for temperature and for humidity. So this transforms every value x in the array to a number between 0 and 1. So value equal to the minimum becomes 0, and value equal to the maximum which become 1. So it is scaled proportionally, and we will apply to temperature as well, and to and to humidity as well. So we'll run this and we'll see here the temperature as well as the humidity values are now expressed as 0 and 1 scale. So this np dot min, what it does, and np dot max gets the range of values, and when we subtract it, it will shift the data, so the minimum is 0, and when we divide it by max minus min, means it scales the range from 0 to 1. Okay, now we will detect outliers if it has any outliers. See, in pre-processing, we in NumPy, when we do pre-processing with NumPy, we will perform these steps. So the next step here is this: we will detect outliers, and for detecting outliers, we will implement the z-score method here. We will implement the z-score method. So if you know the z-score normalization, it is used to detect outliers in the temperature field data also, and in this humidity field data also. And this is a common statistical method for finding values that deviate significantly from the average. Now, what is a z-score? Z-score tells you how many standard deviation a data point is from the mean. So it has this formula: z is equals to x minus mu. Actually, I am not finding mu uh, in my keyboard right now. So I just it is a symbol now. You can see this. I have to switch into the scientific calculator. Okay, how can I will give in the see, the outliers formula will be x minus mu upon sigma. So the mu is the mean, and sigma is the standard deviation. So I'm not writing the symbol, I'll just write the mean. X minus mean upon standard deviation. Okay, standard deviation. Okay, I give this here. It means when the z score is near to 0, so value is close to the mean. And when the z score will become greater than 2 or less than 2, less than minus 2, so value is very far from the mean, it means that it is the potential outlier. So we will use this formula now. Z temp is equal to, implement this same formula, temperature field minus, and for mean we will use np dot mean temperature field and divided it by standard deviation temperature field. And declare this variable outliers and have said that where you will find this outliers, np dot where np dot apps z temp greater than 2. So it this np dot apps z temp, it takes the absolute value of each z score. So this is because both high and low outliers matter. And this greater than 2 keeps only the values that are more than 2 standard deviations away from the mean, a common threshold. And this np dot where returns the index position where this condition will become true. So this line actually identifies the position of the outliers. Now we will print the outliers, positions of outliers. First of all, we will know what are the position of outliers. Right, and after that we will print outlier values. We will print outlier values. Temperature field outliers. Okay, now run this program. Set them, it's mean, sorry, नीब लिखा है मैंने. See this module environment. See, we have because we don't have any outlier, so it will create a empty uh, array here, and also it will create this empty index will also not be there because we don't have outliers in our data, right? Now we will visualize our this is the last step. We will visualize our pre-processed data. And so how we will do this, we have again we will in the same case as we have done before, we will set the figure first. We will set the figure size is equals to 8 comma 4. Then we will plot temperature and this is style which we will create. You will see when you visualize this data, and we will give this label original temperature here. will this give this label original temperature, and so this is for showing the original temperature value. Now we will build plot for the scale temperature. So we will take this temperature field. For scaled temperature we have taken this variable, no? Temperature field. So we will take this variable and we will add some style bo dash label is equals to, and label this is equals to means we will label it by field temperature. Okay, field temperature, bracket close. Then we will give the title as usual. We'll give the title temperature readings original versus field. Okay, and we will give the x-axis a label as time in hours. Okay, and we will give y-axis a label as temperature in Celsius. Okay, then I will write this legend, plt.legend. What it does, I'll show you. And we also add this function plt.grid, and in it I have written true, and plt.show. So this is the first graph, and again for the humidity also, because this is the, I just copy this and I just paste over here, and in this temperature I will write temp scaled. Okay, temp scaled. Okay, temp scaled, and I will write here G and O. Okay, and I will label will be scaled temperature. Scale temperature, then here I will write humidity scaled. Humidity scaled, and m dash s, this is the style I am adding, and I will write this scaled humidity. Scaled humidity. Okay, in blt.plot humidity scaled, and this I will write this add this style label is equals to scaled humidity, and I will give this a title normalized temperature and humidity. Normalized temperature and humidity, and I will plot this x label as time as it is. Okay, and this y label I will give normalized value. Okay, normalized value means 0 to 1, right? And now this now I will show now I will just give you this description, what is R, what is O. So it is a style. Okay, this R stands for red color, this O stands for circular markers, and this dash lines means dash lines. Okay, so this original temperature, so in this we will show these missing values as gaps in the line. Okay, and when we see this line here, so this plots the temperature with missing values filled. Okay, so we will set the style as B stands for blue color, O stands for circular markers, and this will only represent a solid line. Okay, so this line will appear smooth and continuous since no values are missing. And for the yes, again for X label we have given this title label time, and this for Y label we have given this label temperature values in degrees Celsius. Now what this plt dot legend does, it shows the color labels for original and fill data. So it is the function which shows the color labels for the original and fill data what we have set this. And this plt.grid, it shows a grid for easier reading, and plt shows here renders the full plot. And again when we see this normalized temperature and humidity, we will see here we will set the size, where then we will this temperature scale means this will be represent as green color for is green line for scale normalized temperature. O will be a marker, and this dash means solid line. And again for this humidity we have set the color as magenta, uh, magenta line for scaled humidity, and S is square markers. Okay, so now both temperature and humidity values are in the same range 0 to 1, so they are comparable. And again we have given this title, we have given this X label, we have given this Y labels. So uh, and same as above, plt.legend shows distinguishes between temperature and humidity, and this plt.grid shows helps line up values, and this plt.show renders the final plot. Okay, so when we will run this, yes, you can see here, see this, you have seen this here. Actually np.nam values here. This is the fill temperature which we have already filled because we have already filled the temperature, right? Original temperature. This blue solid line, because it is represented as clean, because already we have filled this missing values with a mean. So that's why we have this clean filled temperature data. We don't have these red lines. So if the missing values is occurring in at any row, so it will represent as red line. But because we have already filled the data, that's why it appears neat and clean. Okay, and this here you can see this green line is the scaled temperature, which is normalized to 0 to 1. See this normalized value 0 to 1, and this magenta line humidity normalized to again 0 to 1. So you can easily compare trends and patterns between them. Okay. So today we have generated our own data set. This is the small pre-case study upon pre-processing of the data. How we will pre-process our data. We have generated our own data set, and we have performed a statistical analysis, we have detected and handled outliers, and we have normalized our data. So these are foundational steps for any data science or when we have to do any analytics task, right? And yes, that brings us to the end of Unit 2 of our value added course. I just want to say a big thank you to all of you for your active participation and curiosity throughout these sessions. I hope you now feel confident in generating data and performing statistical analysis and pre-processing data sets using NumPy. And these are the very basic skills that are foundational for any data-driven project. So keep experimenting and keep exploring and apply these methods and functions in your own data sets or in your own mini projects. Once again, thank you for all your active participation, and remember, learning doesn't stop here. Every data set you explore and every problem you solve is a step towards a stronger data professional. So keep practicing, stay curious, and keep pushing your band boundaries. Thank you so much.